Hello everyone, before starting off our video discussion about the mystery part, I would like to introduce myself as Rona Angelina Guerra from STEM 210. Now for the statement of our problem, how does freezing point affect the dissolution of salt in water and its relevance to different industries? To answer this question, we proposed a topic entitled as Utilization of freezing point depression in ice cream making and storing by the food industry. As we all know, ice cream is a mixture of water as the main component, along with milk, cream, sugar, and then the flavorings. A colligative property known as freezing point depression is what turns this mixture into what we all know and love called ice cream. Now, freezing point depression explains that the addition of solute to a substance lowers the freezing point of the solvent. Now, initially, water has a freezing point of 0 degrees Celsius. But because of the added fat globules such as milk, cream, sugar, and then the flavorings, it lowers the freezing point needed in order to solidify the mixture in order to create the ice cream itself. Now for our experiment, we will be creating an ice cream mixture and another mixture composed of salt and ice water, which helps to create the texture of the ice cream because the added salt will lower the freezing temperature and help create the dessert known as ice cream.
Hi, my name is Margaret and I will be discussing our experiment about the application of freezing point depression in ice cream making. The materials we used for this experiment are the following. (500 ml whole cream milk, 60 ml sugar, vanilla extract, ice cubes, 250 ml rock salt, a towel, spoon, and 2 resealable bags, 1 smaller bag for the ice cream and 1 bigger bag for the ice cubes. Now that we have gathered all the materials, here's the procedure for making the ice cream. First, pour the whole cream milk into the smaller resealable bag. Then, the next step is optional, but we can add 60 ml of sugar and a splash of vanilla extract for sweetness and flavor. Afterwards, make sure to remove all air inside the bag and seal it securely to avoid spilling. Shake the bag lightly until the sugar has completely dissolved. To chill the ice cream mixture, pour the ice cubes into the larger bag and add 250 ml of rock salt. Next, place the smaller bag with the ice cream mixture inside the larger bag of ice and seal it tightly. With a towel, shake the bag vigorously for about 5 to 10 minutes. Check the ice cream texture from time to time. If the ice cream has reached the preferred texture, it is ready to be served. Now let's discuss the results of the experiment. After vigorously shaking the mixture, the liquid ice cream turned into solid with a soft and creamy texture. There are some ice crystals found in it from the water residue in the milk which was spun out during the shaking procedure. Furthermore, the ice cube's temperature dropped, which enabled the ice cream to freeze despite the 10-minute time of shaking the mixture. Conclusion. The principle observed in this experiment is the colligative property of freezing point depression, wherein the addition of solute lowers the freezing point of the solution. For example, the freezing point of water is 0 degrees Celsius. However, as observed from the experiment, the addition of rock salt caused the freezing point of water to become lower than 0 degrees Celsius, allowing the ice cubes to be colder in essence. This occurs because the rock salt obstructs the water molecules from forming bonds and crystallizing. As salt absorbs energy from the surroundings to turn the ice into liquid, the whole system's temperature became lower. Therefore, since the temperature must be lower than 0 degrees Celsius for the ice cream to harden, the ice with rock salt enabled the mixture to solidify over the procedure of shaking the batter.
Hi there, my name is Kristen Maala, you can call me Tan. Today, I will be showing you the most common misconceptions regarding freezing point depression and boiling point elevation. Since a lot of people tend to misunderstand some concepts about the topic, we are here to clear all that out and tell you which are the facts.
For our first misconception, boiling point elevation and freezing point depression are caused by intermolecular attractions. The truth is, freezing point depression and boiling point elevation only occurs due to the addition of a solute. For our second misconception, it states that liquids with higher density have lower freezing temperature and higher boiling temperatures. The truth is, different densities of liquids can certainly have different freezing temperatures, but the variation in density is not the main factor for this. Differences in freezing points are caused in particular by differences in the strength of ionic and molecular interactions in various liquids. For the third misconception, it states that change in temperature during freezing are caused by various freezing points of the solution's components. The truth is, freezing temperature of a solution depends to its concentration. The more solute dissolved in a solution, the bigger the change in colligative properties. For our fourth and last misconception, a solute must be involatile in order for freezing point depression to occur. In the case of a volatile solute, the freezing point either remains constant or rises. The truth is, a solute's volatility or involatility is not a determining factor to a solution's freezing point depression. Therefore, the freezing point depression of all solutions does not depend to the volatility of a solute. That is all for our misconceptions. There are many more misconceptions that surround freezing point depression and boiling point elevation. However, these are one of the most common misconceptions that we have gathered.